Welcome to our NPTEL courses on power quality improvement technique. Today is our last lectures and we shall conclude the subject and we will brief you that what we have discussed all those 39 lectures. So, power quality has many problems and it can be the transient stability and you know that the STATCOM is a device, that is a fax devices, can give you a solution of all those problems. So, power quality, transfer capacity, oscillation, damping. So, if you see that power quality problem, so solution we try to find it out through STATCOM or the UPQC. All the current generated problem we generally use the STATCOM. Now, we want to just revisit it for sake of the understanding it. For AC circuit, voltage and current are varying sinusoidally. They have the basic properties like RMS voltage and current. Then the frequencies has to be 50 and 60 hertz. Then it has to be have a phase with a desired maintenance ratio that it should not have a long phase lead and phase lag. So, phase involves both voltage and current and then VI said to be in a phase, that is what the desired requirement of the power quality. Now, some instant peak at the same instant it should have a zero crossing at the same instant. Sometimes zeros are at the different instant, that I will show you the picture. Reverse polarity directions also in a same instant, then let us see that this problem. So, voltage and current are said to be the out of phase when they are 180 degree of their phase angle. So, when you are charging and discharging the battery, then when you are charging the battery, voltage and current are in a same phase, but when through the active filter, once you have this thing, once you discharge the battery, you can have a 180 degree phase shift and peak voltage and I is 0, the I peak and V is 0. So, then in general V and I are neither in a same phase or out of phase. Now, they are somewhere in between. So, we can then split to the current into the in phase component and the reactive component of it. It is possible to provide to split this into the two components. So, we define that as if it is apparent power, that it is the P square plus Q square, then similarly we can split the current. So, you know that active power equal to V into IA and the reactive power equal to V into IR, and thus the apparent power is V into I. So, these are the few basic, you are aware of it, and how much I is communicated through something called the power factor PF, that is something we require to understand it, IA equal to I into PF. So, P equal to S into PF. So, similarly, this is the for the resistive load with a power factor equal to 1 unity power factor. This is the inductive load some way where power factor less than 1, and this one is a capacitive load where it is minus 1. Now, aim of electric power supply, that is your utility, to supply electric energy to the terminal of the electric component, that is the role of the your grid. So, thereafter to maintain the voltage at the electrical equipment terminal voltage within a certain limit. So, what else? So, for the decade, research and the education have been concentrated on the supply of electrical energy at the consumer end, and quality of the power was not come into an issue. The change of the attitude came with adjustable speed drive in 1980s, and starting from the industrial and the commercial power system, spreading to the public supply, the power quality problem also appeared. So, if it is a government, we have to take, we do not have a problem. Now, we have a multiple power supplies, these are run by the private agencies and they have been charged commercially. For this reason, they have a liability to give you the clean power and you also have to pay more for it. Moreover, modern semiconductor switching devices are being utilized more and more in a wide range of application in a distribution network, particularly in domestic and the industrial loads. So, we have discussed these issues. These power electronics devices offer economical, reliable solution to better management and the control of the electrical energy. These devices aggregates the thousands and have become a main source of pollutions and main distortion to the modern power system. So, ultimately culprit is the power electronics, but we are trying to find solution by the power electronics. Now, what else? Microelectronics processes are used in automated industry, assembly lines in hospitals that we have discussed, and we know these are the problems. That is, power quality have following problem mainly the voltage sag, voltage swell, asymmetry, voltage flicker, voltage fluctuations, harmonics and so on. The problem may reduce product quality and cause the huge economic loss, even though that basic purpose get defeated. You use power electronics to have economic reasons and greater reliability, greater performance of the machine, ultimately find that all it is doing essentially reducing the cost of the component and it damages the component. The loss caused by the voltage supply surplus $20 billion in United States industry service every year. So, what is power quality? Let us define again. We have already discussed it. Equipment has become more sensitive to the voltage disturbance. Equipment causes voltage disturbance, growing need to standardization and the performance criteria. Utilities want to deliver good product. End user have increased awareness on the PQ issue and challenges the utility to improve the power quality. Interest in power quality, most of the industries long interruptions and the blackout have become a rare phenomena. Due to that we have reduced it. So, the results in increasing attention of the second order problems such as short interruption, voltage dips, harmonic distortion, etc. So, now you go to the second level of challenges. Power quality can be measured. The availability of the power quality monitors means that the voltage and the current quality can be monitored on the large scale. So, equipment has become less tolerant to the voltage disturbance, because due to the cut-throat competition you cannot take a long margin of safety. Industrial customers such as are more aware of the commercial losses that of the power quality problem may cause to their process, and they ask for the compensation, and there is an increased need for the performance criteria to assess how good the power company is doing their job. And for example, generation, transmission as well as the distribution of the electricity, and that is also called a deregulation. So, regulatory bodies have to create to monitor the framework of this generations quality, transmission quality and the distribution quality. We have to see that at the generation level there is no problem, at the transmission level there is this transmission loss should be reduced, congestion should be reduced, and in distribution level also you see that there is a power quality problem that has been regulated, and it may be someone is generating, someone is transmitting, and you may hire the transmission network. Someone is putting the HVDC network, you are hiring to transmit your power. It is just like I manufacture a goods, railways is a transmission, ultimately the some consumers are the receivers. Same way electricity has been deregulated. So, thus they have a different stakeholder. So, ultimately if you can get a delayed product due to the derailment of the railways. So, but then we have to point it who held responsible for it, and in this diversified electricity market we require to have a regulator to monitor it, and that ensures that all this stakeholder works properly. Power quality is a combinations of the current and the voltage as well as frequency. So, it involves interaction between the system and the load, and voltage quality concern the deviations of the voltage waveform from the ideal sinusoidal voltage of constant magnitude and the constant frequency. Same way, current quality concern deviation of the current wave from the ideal sinusoidal constant magnitude and the constant frequency. Now, there are other issues. These are transients, usually measures in the microsecond. We have discussed in details. I am not going to detail, just I am touched upon the what I have covered in this syllabus. It may be spike, surge or impulse, characteristics of the transient. So, we have to deal with this magnitude, that is rise time, ring frequency, point on wave, multiple zero crossing and the magnitude. So, due to lack of time I cannot explain, please refer back to my transient class in the overview, there I have discussed all the things. So, this is a unipolar positive, the spikes does not come here, and this one is negative, and this one is bipolar. You have a double peak. This is notches, generally comes due to the thyristor switching, and it may be oscillatory, it is coming in that part of the waveform. So, and thus this is a problem of multiple zero, here you have crossed the 0, again you are crossing a 0. So, this is the problem of the transient that has to be mitigated by the power quality problem. Another example, this is the upstream capacitor switching, till then it was balanced, capacitor of magnitude of 478 volt, 1.22 per unit, maximum deviation is this, duration is 0.006 second, that is 0.3 cycles, frequency is this much, and category, this kind of fault category is 3. You can see that, see here you have undergone the switching, and thus it continues for some time and ultimately it deviates. So, this kind of phenomena are the transient phenomena. Similarly, we can have transient here. So, possible causes of transient is to the power factor capacitor energization, lightning, loss of connections, load or the source switching, or the RF blast. So, possible effect, data corruption. So, it may, if it is a data center, it may certain loss of the data may occur, equipment data, data transmission error, while you are talking you are not able to hear properly, intermittent operation, it may stop due to the flickers, reduce the equipment life, and irreversible problem, that is something may destroy and damages the system heavily, like lightning. I have seen in a lightning in my personal house also, some fans were destroyed and it was beyond the repair. Possible causes of the transient are this. So, thereafter let us talk about the transients, disturbance caused by the sudden change of the power system, and this can be impulsive. So, let us see that. So, these are the ranges of it. Nano, the spectral rise time is 5 nanosecond and typical duration is less than 50. It is micro, it is this one is the 1 microsecond and typical duration is 50 nanosecond to 1 millisecond, and milli it is 0.1 millisecond, generally have a typical duration of 1 millisecond. So, thereafter transient can be oscillatory. This is the example of the oscillatory transients. So, this comes into the pictures, thereafter it goes out. So, these are the spectral. So, it can be low, below 5 kilohertz. it can be medium 5 to 500 kilohertz, or it can be high for 0.5 to 5 megahertz. And based on that, we have a Sachs and Soell we have discussed in detail. So, generally typically it is beyond 10% of the nominal value Sach or interruptions, and increase in the voltage is called Soell, where RMS, what is RMS? So, let us define, you know that it is a root mean square. Quadratic mean is a statistical measure of the magnitude of the varying quantity, where x is digitized sample, you have a n sense sample, you have a like this, that value is your RMS value. Now, this is an example of different waveforms in the same scale. This is a Sach, here voltage has been gone down. This is a Soell where voltage has been gone up, and this is the interruption for some time. This is a variation of the RMS voltage. And this is one example, you know, where starting of the motor, this is blue one is a voltage and red one is a current. You can see that here one starts, you know, it will start at this point, it will has a transient reactance, and for this is high current flows, and gradually it will settle down. This is a small start. So, you will have this transient here. So, what is Sach? Sudden reductions of the voltage we have defined already, and cause of the Sach is the temporary disconnections of the supply and starting of the large motor load or the fault current. So, this is the example of the Sach. So, instantaneous for 0.5 cycle we have explained all those things, just recapitulations. Momentarily it is 30 cycle to 30 seconds, and temporary it is 3 seconds to 1 minute. So, possible cause of the Sach is a sudden change in the load current, fault of the feeder, fault in feeder, or fault in the on the parallel feeder. So, possible effect, process of interruption, again data loss, data transmission, PLC computer malfunctions, SCADA may malfunction, damage of the product. So, Soell, again it is the same thing, it is just opposite of the Sach, it is rise in the voltage, sudden increment of the voltage to 10% to 90%. This is the example of the swelling of the voltage. So, again it will be same for 0.5 to 30 cycles we say instantaneous. If it is 30 cycles to 30 seconds we call it is the momentarily, and otherwise it called temporary. Please see that if it is instantaneous, your value is allowed to be more. If it is temporary, the value is restricted to 10% to 20%. So, these are the again the interruptions can be the same thing. So, this is the interruption, just where you have a total loss of power, and duration can be instantaneous, it can be 0.5, and it can be momentarily for 3 seconds to 1 minute. If it is 3 seconds to 1 minute, it is temporary, where the typical value of the voltage will be like this. It may be due to the blown of the fuse or the circuit breaker operation. So, long duration variation, you know that it is under voltage, over voltage, sustained voltage, these are the parameters. Under voltage 1 minute you can go for 0.8 to 0.9 pu, over voltage it is 1.1 to 1.2, sustained interruption can be more than 1, and thus it is a total blackout, it is 0. Under voltage it is defined as a decreased in RMS value to 90% of the power frequency for more than 1 minute, and causes incorrect setting of the transformer. Over voltage is an increase in the RMS value of the voltage greater than, that is 110% of the power frequency for more than 1 minute, and cause may be the capacitor bank switching the or the overload problem. These are the issues. Now, there is a sustained oscillations. So, long duration variations, and it can have a sustained interruption. Those occurs when the supply voltage stays at 0 for the more than 1 minutes. They are often permanent and require the human intervention of the system to restoration, and cause may be system fault, protection, maltrip, operation intervention, etc. Now, let us come to the harmonic part of the power quality problem. This is one of the major issues here, and it is discussed in terms of the harmonics, which is sinusoid voltage and current, and it has to be operated at 50 hertz. And there is another issue, it is called interharmonic, when the frequencies of the voltage and current are not integer of the fundamental, that terms are the interharmonic. So, cause definitely, as you know and well, that is the nonlinear voltage and current, and what effect of the harmonics are malfunction of the control device, mains, signal systems, extra losses in transformer, capacitor and the rotating machine, additional noise from the motors and the other parameter, and 24 interference. Thereafter, we can have a notches, that is, notching is a periodic transient occurring within every cycle. It can be due to the AC to DC converter switching and the phase to phase circuits by commutation process. Here we see the example of it, there is a notch here, there is a notch here, where thyristor changeovers occurs, it gives a notch. So, that we have, and similarly we can have a flicker. These are the rapidly occurring voltage caused by the sudden large change of the load, and definitely it is due to the rapidly varying loads that require a large amount of the reactive power, such as the sawmill, wood chipper, etc., and we have this kind of flickers problem all of a sudden. And possible causes, definitely the rectified input or the power supplies, non-symmetrical current, intermittent electrical noise from the loose connection, and thus what happened, it overload the neutral of the conductor, and thus it may burn, overload the power sources, low power factor, and reduce the right through problem. So, what is harmonic? You know well. So, this is the integer of the harmonic considering that 50 hertz. Now, if it is fundamentally 60 hertz, let us consider that, and the third harmonic. So, then the composition of the waveform can be this, and we call it is a third harmonic injection, we sometimes intentionally drew in types, but it will be like this. So, it is a contamination if it is available in the waveform. So, then sometime we have this occurs when the diode bridge rectified feeding the RC load, the current will have a distortion power factor, and due to that current only flows in this duration, there will be a notch in the voltages, and current will flow only this duration. So, this is the nonlinear voltage and current with the harmonic. Similarly, the harmonics are typically considered to be a problem when they are always present in a steady state distortion and continuously it is occurring. Though any waveform can have the harmonic, are typically concerned with the cumulative effect of the continual harmonic distortion of the system. So, we are more bothered about what is the overall effect of the system instead of the one cycle or the two cycle. So, for this reason we require to define the individual harmonic, and we know that we can find it out by the Fourier transformation, and to measure the harmonic content we have a few methods, that is mainly the THD, that is total harmonic distortion, and that is a fundamental THD, that are total RMS, the load current RMS, and there can be a interharmonics, that is also another nasty element. So, for this reason this is a harmonic spectrum, you can see that is a fundamental and other being plotted like this. So, this will come when you do the FFT of your current sample or the voltage sample having a harmonic. And so, what happened then due to these harmonics? There are deviations of the power fundamental frequency, and from its specified nominal value of 50 hertz or 60 hertz. This frequency are directly related to the rotational speed of the generator and the supply system. The amount of the frequency shift and its duration depends on the load characteristics, of the generator control system, and due to that what happened, fault in the transmission system, disconnections of the large load and disconnection of the generator, blackout, this problem occurs. Now, effect of the power quality we have discussed thoroughly, and so let us take out this point. Poor PQ will lead to the damage of the equipment and downtown the effect of the equipment, and this subsequently leads to the repair and the replacement costs. So, for this reason we have to take these power quality issues quite seriously. Now, the solution, that is something we have discussed, and let us have a tabular form. If the disturbance is a voltage sag, possible cause is a lightning strikes or a tree or animal contact, and the utility side is a dynamic voltage restorer of the static voltage condenser. Consumer side solution can be your UPS. Over voltage, fault in one phase of the road direction, dynamic voltage restorer, voltage current limiter, high energy surge arrestor, this can be the utility solution, and for the commercial, for the customer side solution is a line conditioner, voltage regulator UPS. So, for interruption it can be a blackout or the blown out of the breaker operation. The solution of the utility side, the solid state circuit breaker, which can restore very fast, and customers has a solution, that is the motor generator set, transient lightning strike, high energy surge arrestor, and we require to produce as a consumer the line conditioner surge arrestor. Harmonic distortion, it is due to the nonlinear load. So, you can have the static condensers, filters, and for us it will be line conditioner filter or active power filter. Another is the earthing practice. So, this is also an important entity. The large number of PQ problem is caused by the inaccurate or the inappropriate earthing. Verification of the earthing arrangement, particularly when harmonics problems are reported, should always be conducted early at the PQ investigation. So, transfer the switch are used from the load from the supply to another, and allowing the choice of the load. What do we do generally? We generally put our single phase load in between line and neutral. We require to put the line and earth. We have to see that RCCB is stripping or not. Then you can say that earth is healthy and current is flowing. Otherwise, you will have a unnecessarily high voltage. It is a power electronic circuit breaker. What does it do? This is a static circuit breaker. It can make and break the circuit very fast. The static breaker allows the isolation of the fault, the circuits in a shortest possible time, and thus it improves the power quality. Thereafter, we can talk about the solution like active filter and SVCs. Control the Q and the harmonic can be achieved by controlling the proportion of the power controller. This is done by inductor and the capacitor in the shunt with the power system using the thyristor. With SVC, the control of the current is achieved by the controlling the output voltage and magnitude of the inverter, and SVC is used to absorb or inject the current to eliminate the harmonic, distorting the current through the nonlinear load. Similarly, extension of this is UPFC or UPQC, so that will overall compensate the load. Now, this is called the custom power devices that comes into the picture with the invent of the fax, and so you can see that this is the power transmission, and that will help to increase the power supply enhancement quality, and some of the fax devices we have already discussed in our first courses are this that can be placed with the power quality issues. So, this custom power device can improve your power quality and the reliability. CPD offers the total solution of the package of the customers, and CPD offers the protections with the high security loads when interruption occurs. So, it can be IGBT or the GTO based. The GTO switches are used for the interrupt large voltage and current having a higher power rating, but switching frequency is less. and some of the custom power devices are DVR, DSTATCOM and UPQC. So, why we go for this solution? It is a robust, versatile, compact, ideal, require minimum maintenance, capable of the condition monitoring system, and operationally it is effective. So, these are the few network configuration type. This type of device, a static current limiter, static circuit breaker, static transfer of switches. In the compensating time, it can be a DSTATCOM, it can be DVR, it can be shunt active power filter, it can be UPQC. So, please recall this, remember this slide, MCQ question will come from this A. Similarly, we have discussed DVR, I am not going to discuss in details. So, it is a series compensations, and thereafter we have DVR should be restored the voltage. We have discussed detail in the UPQC. So, we are not discussing here again, and similarly this is the DVR and the stored energy. So, it can mitigate the sags and the soil. If the sags occurs, it will charge the storage entities. If soils occur, it will charge the storage entity, and when sags occur, it will compensate the soil entity. So, this is the overall basic diagram of the DVR. This is storage unit, so series converter, this is a series filter, and in that way it will compensate the filtering part. And similarly, we require to provide the DL power requirement. It can be provided to the battery, capacitor bank or the flywheels. The reactive power requirement generated by the switching of the inverter, and without require any storage device, you can generate it with the help of the angle between the voltage and current. Similarly, we can have the, we can inject this current and we can write in a Thevenin form. In that way, we can calculate the storage rating and the device. Similarly, there are advantage and a disadvantage. Advantage is cheap and able to compensate the longer voltage sag. Disadvantage is draws the current from the line during the fault, hence the upstream load see the higher voltage drop. So, this is the one of the example of the combining the series and the parallel combination. This is called a UPFC. So, you have a shunt path, it takes the current and it compensates. Again, it has a disadvantage, that is the uncontrollable decelerating voltage, hence it is not able to compensate the deep voltage sags, and for this reason you have to design for the up to a level of the voltage sag. Similarly, we can have another system, energy taken from the supply through the shunt path, and thus it can mitigate the large amount of the current, and this is the combinations, this is the series combinations, and generally we do not use it, we prefer the UPQC. Thank you for your attention. Thank you for showing interest to our to our power quality improvement technique courses, and we are looking forward that your positive feedback, and that will help to develop our courses further. Thank you.